Alright, so I'm going to try to attempt to show how to take Alex's week 5 perspective example and sort of turn that into the completed assignment 2. Alright, so I'm going to look at the assignment outline here and sort of taking in the first part. We'll be using Alex's week 5 O2 perspective, and then for reference we'll also be using Human's week 3 2 automatic animation cube, and this is just for reference for indexed draws. So the first thing that we need to do, other than this miscellaneous stuff, is change the background color and change the window size. So let's do that right away. So your window size can be found in main in this function here. So right now when you click play, you get a window size of whatever is displayed. So you can just change these to whatever numbers you want. I'm just going to leave them here as it's a nice size for me. And then when it comes to changing the background color, you need to find your way to the display function. And here you have your GL clear. This basically just completely wipes the screen before you do the rest of your, transforming and then drawing. So before you do that, you want to do GL clear color, and then you can just set it, any RGB color, normalized to 1. So, you can go 1, 0.6, 0.9, 1, which should get us a pretty nice pink. There you go. And that is step 1 done. Really the only complex thing here. Everything else here is fairly straightforward and self-explanatory. Now we're going to be looking at part 1 here of part 2. So step 1 is to set your camera into perspective mode. And to do that, we have to set, that just involves being in the perspective CPP here, and then setting our camera to the right position, and the camera looking at the origin point is just what happens by default, so there's nothing we actually need to change for that. To set the camera's position, we need to find the function that is setting our initial view. So to find that, we sort of just have to scroll through this whole thing, and eventually we get to the reset view function. So this is where we set our initial position, so we just change this to 5.0f, and there you go. That is step 1 of part 2 done. Next, step 2, this is easily the hardest to do, just because you basically cannot use the cube that Alex has used in this example. So unfortunately, that does mean that all of this that we are using here basically cannot be used. However, there are some salvageable bits. The wire, you can just completely delete, and then any errors that come up here with the draw wire can just as well be completely deleted with no issue here. As for the project itself, we just need the cube, no wire. Now, for the cube colors and vertices, we can look towards Human's examples for that. So as you can see here, this is far more compacted and way less of an eyesore to look at. So this can actually just be completely copied and pasted over. So the cube colors and cube vertices, and there you go. It's a million times better. Then, for cube indices, what we want to be doing is copying these into here. And basically what this is doing is, instead of redrawing the vertices for every quad of our square, we are reusing the vertices. And that's sort of what the benefit of index draws is rather than using, 24 vertices, you now have 8 vertices, but they are reused multiple times for each quad. So this is now what your what this should look like here. And that is, a lot simpler than what it was prior. Now, the one thing you do want to make sure is that all of this is correct. Now, this should, there shouldn't be any issue between the two. We do have position, we do have VAO, IBO, points, and colors. And then this here, these are for the camera. And then, just the unsigned ints that are just required for OpenGL because it's bad and we shouldn't be using it probably. So here, Alex has done something that I don't personally like. He's sort of moved the GL buffer data to that, to sort of this section that we, to this section, which I'm not a fan of. I think it's sort of stupid. So what we're going to do here is all of this, so these are basically, telling OpenGL where in memory it can find the data for the indices, vertices, and colors. So what we're going to do is we're going to sort of copy each one of these. So we can cut that out. And then he actually has already done it here, but, as you can see, the exact same line. So for the indices, we don't have to do it. However, we do have to do it for the cube vertices. So where it says GL buffer data move to draw function, you want to replace that with the GL buffer data thing from draw cube. Then going back to draw cube, we want to get the same thing for cube colors. Now, because Human is terrible and just really bad, he just calls this colors instead of cube colors. So to fix that, we just need to rename it. And then, as you can see, all of our errors are gone. So let's check back in, and then let's see. So create a VAO, IBO, VBO for vertices and colors, bind everything, translate your cube, and then screenshot. So in theory, everything should be fine, and we should now have a index drawed cube. There you go. So that is, without question, the most difficult part. And just to go over, once again, everything I've done, I changed these numbers to the ones that were commented. I replaced these with the exact same ones you can find in humans week 3-2. Just literally copy pasted, nothing else done to them. And then I changed colors to cube colors. Moving down here, the only thing I changed was adding this line and adding this line. And that's it. Those are the only things that I have changed. I have also removed draw wire because we do not need a wire. And that is most of the first step. The last thing we're going to do is we're actually going to set the angle to 45 degrees. And then we are going to offset it by what it says here. So we want our y to be 0.45. So here, we're going to replace that with 0.45. And this is in display. Sorry. And this is, all this is doing, so actually one more thing that I want to do just to make things a lot clearer is we're going to take the GL draw elements and replace draw cube with that. For some reason, Alex decided to sort of put all this random stuff in this function when I feel like it's much easier to put GL draw elements right there. So that is that. That is now your completed step 1. As you can see, our cube has just been, you know, nudged up just a little bit. And there you are. That is your first screenshot. Now, we're going to be moving on to the second step. And for that, we're going to be doing a couple things. First, we're going to be changing the numbers here. So we're going to change VAO equals 0 to VAO equals 1. Points VBO from equals 0 to equals 1. Colors VBO from equals 0 to equals 2. And then we are going to delete IBO equals 0. So now this has sort of set us up to pretty much create a second cube using the same vertices that we had before. This can also be seen in Who-Man's Week 3-2, where you can see that he's using the same IBO, but putting points and colors to 3 and 4 with VAO to 2. And what this is basically doing is just telling OpenGL that this is one model and this is a second model. So what we can actually do is go in here and just looking at this for reference, just seeing how this works. We want to take the whole goddamn thing, Control C, Control V. And if you want, you can, you know, you can tab it out if you want it to look nice. But all we're going to do is change VAO equals 2, points VBO equals 3, colors VBO equals 4. And while we're here, we can also delete GL line width, as we're not going to be using any lines. Alright, just to go over, I changed the equal numbers here, copied this whole section, pasted it, then change the numbers once again. Save that. And now we can move down to our display function. Once again, we can take a look at whomans for reference, which I have just commented out a little bit here. But basically, what the key thing to notice here is GL bind vertex array is at 1. And here, GL bind vertex array is at 2. So rather than being VAO, we just want this to be 1. And this is telling OpenGL, okay, this is your first object you're drawing. Transform that object, then draw that object. Now what we can do is we can copy this, paste it here, fix our tabbing a little bit, and now we're going to tell OpenGL, here is the second object I want you to draw. Now, once again, we just have to fix where this is being placed. So the instructions tell us for it to be placed at negative 0.45, which we can do without too much issue, just adding a negative sign here. And in theory, we should have 2 overlapping cubes. And there you go. Now, that is your second screenshot. That is step 3 done, and your second screenshot. Now, what it is asking us to do is to animate your cubes and rotate each cube in opposite directions. Now, might sound daunting, but it is literally a few keystrokes at best. If you'll notice, up here, we do have an angle float, and that is what we will use to determine the angle of our objects here. What we're actually going to do is we are going to add another angle, and this is just so we can have, you know, one going one way and one going the other way. Simple as that. Scrolling back down to our display function, we're going to replace 45.0f with angle plus equals 1. And for rotation angle on our second object, we're going to do angle 2 minus equals 1. And that is it. That is your completed step 4. As you can see, 2 boxes rotating in opposite directions. Now, we are going to move on to the step 5, which is the final step, and once again, seems quite daunting. Having to figure out keyboard inputs is really confusing in the way that Alex has done it, but thankfully it is mostly just copy and pasting. So the first thing we're going to want to do is we're going to want to scroll up to key masks. Just delete this comment out, add a comma here, and we have forward and backwards, so we need right, and I am actually going to tab all of this to make it look, you know, presentable. So we have key right, left, up, down. Just need to write that in. Left, then we have up, and lastly, down. And the way to do this is you just have to replace So this is, as you can see, binary 1, 2, 4, 8, 16, 32. So you just have to move 1 to the left each time you're going to a new number. So from here, we want to do 1, 0, 0, 0. We want to do 1 with 5 zeros, and now we want to do 1 with 6 zeros. And those are your key masks. Now, to actually change how the keys work, we need to do a few things. Our first thing we're going to do is we're going to delete the key down spec and delete the key up spec. Oops. Then we're also going to delete anything to do with the mouse, as that is not mandatory for us. And then in main, we are just going to delete anything that is causing us errors. Alright, save that. Now, we're going to go from top to bottom, starting with parse keys. Now, what we have here is key forward and backwards, which just affected by W and S. Next, we need key right, and thankfully Alex has provided us with a right vec that we can use to our convenience. Make sure that if this direction is matching this direction, you have a plus instead of a minus. So now that we're doing left, because we're using right vec, because this direction does not match this direction, we're using a minus here. So we just need up, which we conveniently have on up vec. Make sure that is a plus. And lastly, we have a down, which is a minus on the up vec. Next thing we need to do is to actually have our keys be registered within the key down function. And for that, we can simply Control-C this case and match it to what we want. For right, we're going to be using D, and that can be right and right. A for left, left, left. We're going to be using R for up, as per the instructions. Up and up. And lastly, we're going to be using F for down. Alright, that is now the key down function. And the last thing we need to do is to fix up key up. So, very much similar. For D, we have right. For A, we have left. For R, we have up. And for F, we have down. Alright, now, in theory, we should have a working camera system alongside our two spinning cubes. S and W bring us in and out. A and D bring the camera going to the left, going to the right. Remember, we're not controlling the cubes, we're controlling the camera. It's a little disorienting. And then for R and F, we are going up and down. Now you just have to take your 3 screenshots, and that is your fully completed Assignment 2. Now, I would strongly recommend that in between each of these sections that I've been saying, that you do your best to try and figure it out on your own. For example, once I finished step 1, attempt yourself to do step 2. See if you can figure it out using the resources that I am using. But if not, you can watch me do step 2, and then see if you can figure out how to do step 3, etc., etc. Obviously, not everybody can figure this stuff out. It is largely incomprehensible, and we have barely been taught. But I hope that this video will be of assistance to many of you. Make sure to like, comment, and subscribe, and see you in class.